Analytic geometry is a branch of algebra that is used to model geometric objects such as points, straight lines, and circles, being the most basic of these. Analytic geometry is a great invention of Descartes and Fermat. Analytic geometry, also known as coordinate geometry or Cartesian geometry, is the study of geometry using coordinate system. The Cartesian coordinate system, also called the rectangular coordinate system, is based on a two-dimensional plane consisting of the x-axis and the y-axis. Perpendicular to each other, the axes divide the plane into four sections. Each section is called quadrant. The quadrants are numbered counterclockwise. So we have here the diagram of a rectangular coordinate system. The horizontal line is the x-axis, while the vertical line is y-axis. And we have four quadrants. Upper right is quadrant 1, and upper left is quadrant 2, and lower left is quadrant 3, and lower right is quadrant 4. The center of the plane is the point at which the two axes cross. It is known as the origin or point 0, 0. From the origin, each axis is further divided into equal parts. Increasing means positive numbers to the right on the x-axis and up the y-axis, while decreasing or negative numbers to the left on the x-axis and down the y-axis. The axes extend to positive and negative infinity as shown by the arrowheads. So we have here the point or the origin, which is at 0, 0, positive value along right axis or right of the x-axis and negative value at the left axis, while positive value on the upper y-axis and negative value on the lower y-axis. We have a two-dimensional plane where the x-axis is the horizontal axis, y-axis is the vertical axis. A point in the plane is defined as an ordered pair, which is x, y, such that x is determined by its horizontal distance from the origin and y is determined by its vertical distance from the origin. So this will be the format of a point, always the distance along x, comma, the distance along y. Derived from the Pythagorean theorem, we need to find the distance between 2 points, and the distance formula is used to find the distance between 2 points in the plane. The Pythagorean theorem, which is a squared plus b squared is equals to c squared, is based on a right triangle, where a and b are the lengths of the legs adjacent to the right angle, and c is the length of the hypotenuse. So we have here the diagram of two given points, point 1, which is x sub 1, comma y sub 1, and point 2, x sub 2, comma y sub 2. And the horizontal line along the x-axis, A, and the vertical line, which is B. And we have a 90-degree angle. Connection from point 1 to point B is distance D or the hypotenuse C. And using the Pythagorean theorem, which is c squared equals to a squared plus b squared, or c is equals to the square root of a squared plus b squared, the two adjacent lengths of the angle, right angle. Substituting, we have d squared, wherein c is equals to d, b is the difference of 2 points along y-axis, which is y sub 2 minus y sub 1, and it is equal to b, while x sub 2 minus x sub 1 is equal to a along x-axis. And by substituting, d squared is equals to x squared minus, or x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and the distance formula, d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is the distance formula. We have midpoint of a line segment. Midpoint of a line segment, or when the endpoints of a line segment are known, we can find the point midway between them. This point is known as the midpoint, and the formula is known as the midpoint formula. Given the endpoints of a line segment, which is x sub 1, comma y sub 1, and x sub 2, comma y sub 2, the midpoint formula states how to find the coordinates of the midpoint M. We have point 1, which is x sub 1, comma y sub 1, and point 2, x sub 2, comma y sub 2. And using the midpoint of a given line, we have the summation of x values along x, which is x sub 1 plus x sub 2, and then we divide by 2 is the distance at midpoint along x, while y sub 1 plus y sub 2 are the summation of all y values, and we divide by 2, and this is the point midpoint along y distance. Or the formula for midpoint of a line segment is equal to x sub 1 plus x sub 2 all over 2 along x distance, comma, y sub 1 plus y sub 2 all over 2 along y distance. Angle of inclination or slope. Angle of inclination, also called simply the inclination of a straight line, is the smallest positive angle from the positive x-axis to the line. The slope of a line is the tangent of the angle of inclination. Slope is usually denoted by m, or m is equals to tangent theta. We have p1 or p sub 1 x1 y1, x sub 2 y2 or point p2, and the difference between y-axis is y sub 2 minus y sub 1, and the difference along x-axis, which is x sub 2 minus x sub 1. And the slope formula, wherein opposite over adjacent is the tangent theta, and the opposite value is y sub 2 minus y sub 1, while the adjacent value is x sub 2 minus x sub 1. And we change the slope to m, where m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And this is the angle of inclination, or simply the slope. Parallel and perpendicular lines. Two non-vertical lines with slopes m1 and m2 are: first, if it is parallel, if the lines have the same slope, or m sub 1 is equals to m sub 2. And we can say that it is perpendicular if the slopes are negative reciprocals, or m sub 2 is equals to negative 1 over m sub 1. Or equivalently, if m sub 1 times m sub 2 is equal to negative 1. In this diagram, we have the red line with 2 points, and we can find the slope m1 using the formula for slope. And the blue line is the another slope, which is m sub 2, and based on the theorem for parallel and perpendicular lines, m sub 2 is equal to negative 1 all over m sub 1. So we have the formula: if it is parallel, m1 or m sub 1 is equals to m sub 2, even, and if it is perpendicular, m sub 2 is equals to negative 1 over m sub 1. Example number 1. Find the distance between the given points p sub 1, which is 1, 3, and p sub 2, which is 7, 6. And we identify first what is x sub 1, x sub 2, y sub 1, and y sub 2. P1, we have x sub 1, y sub 1, and P2, x sub 2, y sub 2. And based on the rectangular coordinate system, we have the x-axis and y-axis, and the origin
or 0.00, and then we plot. So P1, we have 1 comma 3, or x sub 1, which is 1, and P y1, which is equal to 3. This is 1 and 3, and this is the point, which is equivalent to P sub 1, 1 comma 3. And then P2, 7 comma 6, 7 along x and along y, which is 6. So 6 and 7, and this is the point, and this is equivalent to P2, which is 7 comma 6. We connect P1 and P2 to form a line, and we have a line from P1 to P2. Using the distance formula is equal to d, or d is equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we substitute based on the given. X sub 2 is equal to 7 minus x sub 1, which is equal to 1 squared, plus y sub 2, which is 6, and minus y sub 1, which is equal to 3 squared. And then we simplify. Square root of 7 minus 1 is 6 squared, plus 6 minus 3 is 3 squared. And simplify. 6 times 6 is 36, plus 3 times 3 is 9. And the total, d, is equal to square root of 45. And to simplify, we have a perfect square of 3 times 5, or 3 square root of 5. And this is the value for distance between P1 and P2. Example number 2. A triangle has vertices A, 12, 5, B, 5, 3, and C, 12, 1. Show that the triangle is isosceles. And we have the coordinate system. We have x-axis and y-axis, and the point of origin, which is 0, 0. Now we need to plot the points A, B, and C. So we will designate point A as x sub 1 comma y sub 1, point B x sub 2 comma y sub 2, and x, or C, x sub 3 comma y sub 3. Then we plot A, which is 12 at along x, and 5 along y. So we have 12 and 5, and this is point A, 12 comma 5. Point B, 5 comma 3. So we have 5 along x and 3 along y, and this is the point, which is equivalent to B 12, 5 comma 3. C, we have 12 and 1, and this is the point, which is equivalent to C 12 comma 1. We connect from A to B, B to C, and C to A. From A to B, next from B to C, and C to A. Based on the diagram that the two sides are equal, we presume and possible that AB, the distance AB, is equal to distance BC. And we need to prove that AB is equal to AC using distance formula. So line AB should be equal to line BC. And at line AB, we have the points 12 comma 5 and 5 comma 3. So the distance formula, d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. At AB, we have 12 comma 5 and 5 comma 3. So we designate this as x sub 1, y sub 1, and this is x sub 2, y sub 2. D at AB is equal to the square root of x sub 2 is 3, x sub 2 is 5 minus x sub 1, which is 12 squared, plus y sub 2, which is 3 minus y sub 1, which is 5 squared, and square root 5 minus 12 is 7, or negative 7 squared, plus 3 minus 5 is negative 2 squared, and we simplify. Negative 7 times negative 7, so it's even number, the sign is positive, so 7 times 7 is 49, plus negative 2 times negative 2, still even sign number, so therefore it is positive sign. 2 times 2 is 4. 49 plus 4 is equal to square root of 53. So the distance dv is equal to square root of 53. Next, distance at BC, or line BC, and the points are 5 comma 3 and 12 comma 1. Using the formula for distance d at BC, we have, this should be x sub 2 square root of 12 minus 5 squared plus 1 minus 3 and squared. 12 minus 5 is positive 7 squared, plus 1 minus 3 is negative 2 squared, and square root of 7 squared is square root of 49, plus negative 2 times negative 2 is positive 4, and the value for BC, or the distance BC, is equal to square root of 53. Therefore, d of AB is equal to distance of BC. Therefore, it is an isosceles triangle. And this is number 2. Example number 3. If the midpoint of AB is negative 3, 8 and A is 12, negative 1, find the coordinates of B. Identify first what are the given, and the given is the midpoint. So we have midpoint, which is equivalent to negative 3 and 8. Then point A, which is equivalent to 12, negative 1. And we need to find the value for our point B. So this is x sub 2, y sub 2. And the formula for midpoint along x, at x axis, we have x is equal to x sub 1 plus x sub 2 all over 2. And the value for x sub 1, which is at point A, is equal to 12 plus x sub 2, which is the unknown, and we divide by 2, and the midpoint at x, which is negative 3, and then we simplify. Negative 3 times 2, this will be negative 6, and this is 12 plus x squared, and x sub 2 is equal to negative 6 minus 12, and x sub 2 is equals to negative 18. At y-axis, y is equal to y sub 1 plus y sub 2 all over 2. And based on the given that midpoint is negative 3, 8, we have y, which is equal to 8. And this is 8 is equal to y sub 1 is at point A, which is negative 1, plus the unknown y sub 2 all over 2. Cross multiply 8 times 2, this is 16, and it is negative 1 plus y sub 2. And y sub 2 is equals to 16 plus transpose to the other side, which is positive 1, and y sub 2 is equals to 17. So therefore, point B is at negative 18 comma 17, and this is the point B. Example number 4. A line passes through negative 5 comma 8 with a slope of 2/3. If another point on this line has coordinates x comma 12, find x. So we have a point which is negative 5, 8. So we have negative 5 and positive 8. So this is the point. And this is negative 5 comma 8. The given slope, which is 2/3. We presume that negative 5, 8 is point A. So A is negative 5 comma 8, and the slope m is equal to 2 over 3, and point B is equal to x 12. So we need to find the value of x using the slope formula, and the slope formula is equal to m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And in this case, point A is negative 5 comma 8, or this is x1 y sub 1, while x negative 12 or x comma 12, this will be x sub 2 comma y sub 2. And then we substitute. Y sub 2 is 12 minus y sub 1, which is 8, all over x sub 2 is equal to x minus x sub 1, which is negative 5. Value of m or slope is 2 over 3. And we simplify, cross multiplication. So 2 times x plus 5 is equal to 3 times 12 minus 8 is equal to 4. And this is 2x plus 2 times 5 is 10 is equal to 3 times 4 is 12. And 2x is equal to 12, transpose 10 to another other side, which is negative 10, and this will be 2x is equal to 12 minus 10, or 2, and the value for x is equals to 2 over 2, or x is equal to 1. And this is the value for x, which is equivalent to 1. Example number 5. Verify that the points P1, negative 1, comma 3, P2, 0, comma 5, and P3, 3, comma 1 are the vertices of a right triangle. So we need to plot the 3 points and form a triangle, and it should be a right triangle. So P1 is negative 1, 3, so negative 1, 1, 2, 3, and this is the point. And this is negative 1, or P1, negative 1, 3. Next, P2, 0, comma 5. So 0, comma 5, and this is the point. This is P2, which is 0, comma 5, and P3, which is 3, comma 1. So 3, comma 1, and this is the point. And this is P3, which is 3, comma 1. And we connect P1 to P2, P2 to P3, and P3 to P1. P1 to P2 and P2 to P3, and last P3 to P1. Based on our plot, point P1 form a right angle, which is 90 degrees. Therefore, using the parallel and perpendicular lines, we need to identify what is the slope of P1, P2, or P1, P2, and the slope of P1, P3. And we need to prove that the angle formed between P1, P2 and P1, P3 are 90 degrees. So M2 is equal to negative 1 over M1. And we presume that P1, P2 is equal to M1, and then P1 and P3 is equal to M2. At P1, P2 with the points negative 1, 3, and and 0, comma 5, M1 is equal to 5 minus 3 all over 0 minus 1, and this is 5 minus 3 is 2 all over 0 minus 1, or positive 1, and M1 is equal to 2. Next, at P1, P3, the points are negative 1, 3, and 3, 1, and this will be slope M2. So this is the slope M1, and this is slope M2. So M2, we have y sub 2, or 1, minus y sub 1 is equal to 3 all over x sub 2, 3, minus x sub 1, which is negative 1, and this is 1 minus 3 is negative 2 all over 3 minus 1, or 3 plus 1, or 4, and M2 is equals to negative 1 over 2. So therefore, M2 is equals to negative 1 over M1, or this is negative 1 half is equal to negative 1 over 2. And we prove that the 3 points form a right triangle. So this is a right triangle. And this is problem number 5.